Hi everyone, for today's lesson, we are going to continue with our discussion over geometric proofs. In this lesson, please make sure that you have completed the discussion notes for geometric proofs. In our discussion notes, we discussed what a theorem was and what a postulate was, and we are going to be using theorems and postulates to help us to prove certain statements are true in geometry. One of those statements, or a couple of those different properties that we learned about, was the reflexive property of congruence and the transitive property of congruence. The reflexive property, remember, is kind of what I call the mirror property. And what that means is that all segments and angle measures, they are congruent to itself. Now, notice that I'm not working with numbers here. Whenever we're working with congruence, we're talking about a relationship. And the relationship that I want you to know when it comes to the reflexive property is that all segments are congruent to itself. And what you're going to see in pictures, or what you might see in different kinds of proofs that we have, not just in this unit, but in future units, is that you might see where you have two different figures. Like in this case, I have two triangles. And both of these triangles share the same segment or share the same side of AB. And whenever you see that common side or shared side, that indicates that those two sides of each respective triangle are congruent to each other by the reflexive property of congruence. Same thing if you have a triangle inside of another triangle. They would both share an angle, and therefore angles are congruent to each other. Notice that whenever we're working with segment length, we need to have the line above because we are talking about a relationship and not an actual number. So that's why we have the line above to represent length of to represent a segment name. And with angle measures, we have no M. The M, remember, represents a number. And whenever we're talking about congruence, we don't want to talk about numbers. We just want to talk about a relationship. The other property that we had was the transitive property of congruence. And I call the transitive property the triangle property. Because in a triangle property, what you're going to see is a relationship statement. Like segment AB is congruent to segment CD. And segment CD is congruent to segment EF. So if you eliminate the piece that they both have in common, the piece that they both have in common when it's eliminated leaves you with your final statement. Look at what we have. Segment AB is congruent to segment EF. So what you're left with, if you eliminate the connector piece, is your answer. That is the triangle, the transitive property of congruence. Once again, you have to have a line above if you're working with congruence. Same idea happens with angles. If angle A is congruent to angle B and angle B is congruent to angle C, well, if you take out the connector piece of angle B, we would say that angle A is congruent to angle C. Once again, we don't have an M in front because we don't really care what the angle measure actually is. We're just talking about a relationship. So that is something I want you guys to please keep in mind whenever you're working with congruence versus equality. In this lesson today, you will want something to write with. You will also want to have some highlighters just for emphasis. But I don't think that you will need any other supplies other than those. So in our first example, what we want to do is we want to name the property that is shown. So it says if angle H is congruent to angle T and angle T is congruent to angle B, then angle H is congruent to angle B. Look at this. We have three pieces of information. And if it's helpful, we can write this out. Angle H is congruent to angle T, and angle T is congruent to angle B. So therefore, angle H is congruent to angle B, and this is an example of the transitive property of congruence. POC represents property of congruence. So before we had POE, that means property of equality. POC means property of congruence. Next we have segment CD is congruent to segment DC. Think think about what that is. Remember that whenever you name segments, we have to use the endpoints. So segment CD and segment DC are the same exact segment. So therefore, this segment is congruent to itself. And this is an example of the reflexive property of congruence. The reflexive property of congruence. Letter C says, if segment DB is congruent to segment ST, and segment ST is congruent to segment GH, then segment DB is congruent to segment GH. If you were to draw this out, we would have segment DB is congruent to segment ST, and segment ST is congruent to segment GH. Therefore, segment DB has to be congruent to segment GH, and this is an example of the transitive property of congruence. There are three pieces of information, one being the connector piece, and this is the triangle property, essentially. We have if, so I don't know why it says if, so sorry guys. We have angle HAT is congruent to angle HAT. If we were to draw what angle HAT would look like, this is a quick sketch. Angle HAT is congruent to itself. Once again, this is a reflexive property of congruence. For example number 2, it says, write your own examples of the given properties. So this is where you get to pick. I'm going to write down my example, but I'm going to encourage you to come up with your own example. So you have a choice. You can either work with segments or you can work with angle measures. It's up to you. I'm going to personally choose if segment AB is congruent to segment JK and segment JK is congruent to segment XY. Then my connector piece is JK, and I'm going to eliminate it, leaving me with segment AB is congruent to segment XY. There's my transitive property of congruence. An example of the reflexive property of congruence would be something like this. It's not if then. We would have angle maybe JKL is congruent to angle LKJ. All I did was reverse the letters. And remember that there are many ways to name an angle. So if I had angle JKL, we always name an angle with the center being in between. Since both of these contain the same letter between, LKJ and JKL are the same exact angle. So this would be an example of the reflexive property of congruence. You don't have to rearrange the letters. You can if you want to, but you don't have to. So these are my examples. I recommend coming up with your own. You will be asked to create your own potentially on a quiz or a test. So make sure that you feel comfortable coming up with with examples of these. Next, we are going to go on to our proofs. So I am always going to give you all of the fill in the blanks on the side. Eventually, I'll give you too many blanks, but in the meantime, we are going to you will always have the blanks on the side. And what we have here is given ray BD bisects angle ABC. Now remember that the word bisect means to cut in half. So to cut in half means that these two angles have to be congruent to each other, angle 1 and angle 2. Or angle ABD and angle CBD would have to be congruent to each other. And what I also know is that angle 1 plus angle 2 would equal the whole angle, so that could be where I would work with the angle addition postulate. And I want to prove that the measure of angle ABC would now be 2 times the measure of angle 1, which wouldn't that make sense? If angle 1 and angle 2 are the same exact measure, If I just double angle 1, it's going to equal the whole angle. That makes sense to me. So now let's go ahead and prove this. I already have the statements written for you, and now we have to come up with the reasons. And when it comes to the reasons, it's all about what came before and what comes next. If is what came before, then is what came next. So let's talk about number 1. First of all, ray BD bisects angle ABC. We write that because it is given. So the first blank where it says given, that goes away. Next, it says angle 1 is congruent to angle 2. Why would we say that? Well, what came before? What came before was the word bisect. And we know that if we have a if we have an angle bisector, then it cuts that angle into 2 congruent angles. So if an angle is bisected, then it divides that angle into 2 congruent angles. And that's why we write angle 1 is congruent to angle 2. So let's look at what I just said here. If a ray bisects an angle, then it divides an angle into 2 congruent angles. And that's why we write our answer. So the next thing that we're going to write is this next statement. And you're welcome to use shorthand. I would say if a ray bisects an angle, so this is a symbol for angle, then it divides the angle into 2 congruent angles. So that is using the shorthand version of angle. So if you want to put like the arc in between just to say that it's an angle, if that will help you, then that's fine. I was using the old-fashioned division symbol to represent the word divides. Then it divides an angle into 2 congruent angles. We use a lot of shorthand when it comes to proof, so I want you guys to feel comfortable with using these symbols to represent words. Next, number 3. It's all about what came before and what comes next. What came before was angle 1 is congruent to angle 2. And now we're saying the measure of angle 1 equals the measure of angle 2. So we go from congruent to equals. If 2 angles are congruent, then they are equal in measure. And that's what you're going to write down. If 2 angles are congruent, then they are equal in measure. So if 2 angles are congruent, then they are equal in measure. I am expecting that you are going to write down the entire if-then statement, the entire conditional statement. And as you write down the entire statement, then we are able to move on. If you miss a piece of that if-then statement, then that's not considered correct because it's all about what came before and what comes next. Let's go ahead and look at number 4. This is supposed to be 5 and 6. Whoops. All right. So what we have here is we have the measure of angle 1 equals the measure of angle 2. And then we have the measure of angle ABC equals the measure of angle 1 plus the measure of angle 2. So let's look at what that is. The measure of angle ABC equals the measure of angle 1 plus the measure of angle 2. So ABC is the whole angle. And it's equal to the measure of angle 1 plus the measure of angle 2. This looks a whole bunch like the angle addition postulate. So it's not, in this case, because it's not going to be an if-then statement, we're going to say that our 4th reason for why we would write this down is the angle addition postulate. Next, we are now on step number 5. for step number 5, it says, okay, we had the measure of angle ABC equals the measure of angle 1 plus the measure of angle 2. Now we're saying the measure of angle ABC equals the measure of angle 1 plus the measure of angle 1. So what is different here? Well, what's different is that instead of us working with the measure of angle 2, we're talking about the measure of angle 1 twice. And where that came from is the fact that we know the measure of angle 1 equals the measure of angle 2. So what happened here was a replacement. And we call replacements the substitution property of equality. So what reason why we're writing this is that we are substituting. The measure of angle 2 with the measure of angle 1 based on information that came before. So this is the substitution property of equality because we are working with an equal sign. And now look at this. Measure of angle ABC equals 2 times the measure of angle 1 plus the measure of angle 1. And what we have done here is we've combined our like terms or simplified this. Think about it. If this was the measure of angle ABC is equal to x plus x, wouldn't we just write that as the measure of angle ABC is equal to 2x? We would just combine our like terms, and that's essentially what we have right here. So we can call this combine like terms or simply simplify. And that's why we wrote our answer, because we simplified the expression. And now we are done. All right, let's go ahead and look at our last example. In this example, we are told that R is the midpoint of segment AM. So let's go ahead and mark that. R is the midpoint of segment AM. Remember that the midpoint cuts the segment in half. And not just in half, but into 2 congruent pieces. And what we want to prove, and what we also are given is that segment MB and segment AR have the same length. They are equal in length. So therefore, if RM and MB are equal in length, we can therefore say, or we want to prove, that M is the midpoint of RB. So this markings that I'm putting into my picture and me writing down information, this is thinking. This is how you are showing me work with these types of problems, because when you are checking your answers with the proof, obviously you're going to already have the answers, but I want to see the thinking. What did you do to try to gain a sense of what you were doing here? So I can see that I might be working with maybe the substitution property, a replacement property. I know that I might be working with the definition of midpoint. So there's a lot of pieces that I might be working with. But number one thing that I know is that my first statement, R is the midpoint of segment AM and MB equals AR, I'm going to write that because it is given. And writing something because it is given is always our first step. Now it's all about what came before and what comes next. So we are told that R is the midpoint of segment AM, and now we're saying segment AR is congruent to segment RM. Why are we allowed to say that? Well, that's because what came before was midpoint. And if we have a point as a midpoint, then it cuts or divides a segment into 2 congruent segments. So what came before was midpoint. What comes next is congruent segments. Let's look for that. If 2 segments are congruent, then they are equal in measure. No, if a point is a midpoint, then it divides a segment into 2 congruent parts. That is what we are looking for here. So we want statement number 2, what came before was midpoint, and that's what I have here. If a point is a midpoint. then it divides a segment into two congruent parts or segments. You can also say segments as well. If a point is a midpoint, then it divides a segment into two congruent parts. Be careful. There's another one that says if a point divides a segment into two congruent parts, then it is a midpoint. That is not the same thing. They look the same, but they are a converse of each other. And to make a decision as to which one you use, it's all about what came before and what came next. Midpoint was first, so if has to have the midpoint first. What came next was two congruent parts. Statement 3. We have segment AR is congruent to segment RM, and now we have AR equals RM. So we went from congruent to equal. So if two segments are congruent, then they are equal in length. That's what we are going to write down. If two segments are congruent, then they are equal in length. Next, let's go ahead and look at what we have next. AR equals RM, and B equals RM. Why are we allowed to say that? Let's go back to where we are at. We have already worked with the midpoint information, but now we have MB equals AR. So if MB equals AR and AR equals RM, then MB equals RM. If MB equals AR and AR equals RM, then MB equals RM. What are we using here? What did we do? We did a replacement. We did a substitution. We could have in this next step maybe the transitive property of equality, or you could use the substitution property of equality. So for this one, I'm going to say or the transitive property of equality. It depends on how you want to view it. But what we have here is a replacement. We have MB is equal to AR, and AR is equal to RM. So you always take away the connector piece. So what happened is we replaced AR with MB. So sometimes the substitution property of equality and the transitive property of equality can be kind of mixed. It depends on the type of problem, but we're going to say the substitution property of equality. So now let's look at what happened going from 4 to 5. MB equals RM. Segment MB is congruent to segment RM. Equals to congruent. Equals to congruent. If two segments are equal in length, then they are congruent. That's what we're going to write down for statement 5. So if two segments are equal in length, then they are congruent. And now finally, we have segment MB is congruent to segment RM. Segment MB, so this segment right here, is congruent to segment RN. So if you have in this segment from R to B, both sides being congruent to each other, that indicates that point M has to be a midpoint. So what came before? We have congruent segments where a point divides a segment into two congruent segments. That was point M. Then that point has to be a midpoint. So if a point divides a segment into two congruent parts or segments, then the point is a midpoint. And that is our last fill in the blank, as well as the end of this lesson. If you have any questions over anything that I just showed you, please feel free to email me. Otherwise, I hope you have a wonderful day.